Hello, there's a question number 4 from JEE Advanced 2020, paper 1. It reads a circular coil of radius r and number of turns capital N has negligible resistance. As shown in this schematic diagram, its two ends are connected to two wires and it is hanging by those wires with its plane being vertical. The wires are connected to a capacitor which has a charge Q and a switch. The coil is in a horizontal uniform magnetic field B not parallel to the plane of the coil itself. When the switch is closed, the capacitor gets discharged through the coil in a very short period of time. By the time capacitor is discharged fully, magnitude of angular momentum gained by the coil will be. So we need to find how much angular momentum is gained by the coil. We need to assume that the discharge time is very short. It's so short that rotation is ignored. That means coil is hardly rotated. Now, simple solution can be voiced over here. This is capacitor and it has a charge, let's say plus Q. When the switch S is being closed, then you'll find there will supply a current. And that current will go like this, then flow like this, and then will come this way. When the current moves through this coil, let's say that current is I, you will find this will be a dipole, magnetic dipole. And since this is a dipole present in a magnetic field, so there's a mu, there is a magnetic field, so we know there's going to be torque experienced by this coil. What that torque is going to be, torque on the coil is going to be tau is equal to mu cross B as per the formula. Now this mu is basically n times I into area of the loop. So we will write it as n times I and area, which is pi r square, into magnetic field, which is B naught, and sine theta. When we are writing the magnitude, cross product will have a sine theta. So here you need to write sine, angle between mu. Mu vector is going to be outward to the screen. And B is on this, so they will have a 90 degrees. So this will be 90 degree. Sine 90 is 1. So it will not be there anymore. Anyway, moreover, that current flows through this. So this current is coming because of the charge Q. And this Q charge reduces to 0, let's say in delta t time. So can we say the current is going to be equal to the charge that was changed divided by time change? So delta Q upon delta Q can be written as Q, delta T is the time we are considering, which is very short. Now there's one more definition. We know the torque is equal to rate of change of angular momentum. So this torque must be giving the angular momentum to the coil. So you'll find these two numbers has to be identical. So let's equate these two expressions. So we'll get n pi r square B naught into I. In place of I, we can use Q by delta T is equal to delta L upon delta T. Now delta T will disappear. So this will say change in angular momentum of the coil is going to be pi n Q B naught r square. Now this is change in angular momentum. Initial angular momentum was 0. So this is also going to be equal to the final angular momentum. That means this is the angular momentum that is gained by the coil during that time interval, during which it discharges completely. If you look at the options, then you'll find option B will be most suitable one. Hence B will become the right response. Thank you.